There are two types of problems in this packet. There are the ones that say Form B, which is over here, and the regular ones. You are not taking Form B. That is for the European students. Usually, theirs is harder than the regular form. There has been at least 1 year that I know of, Adam, guys, where the regular form was actually more like a Form B. What I recommend you do is do all the regular ones and then come back, if you have time, to do the Form B problems, because it'll just give you more practice. And you really haven't done anything until you try. You've got to actually start to write something down. When you write something down and you don't get it right, I can look at what it is that you're doing, okay? So that's one thing you want to do. And also the other thing is that questions 1 through 3 are calculator problems. It says graphing calculator right at the top of the sheet. If you get to the last 2 years, they took this off the graphing calculator part of the exam because evidently there's either a program or a calculator out there that if you just type in the functions, tell it what you want it to do, it'll give you the answer. So now it's not in the calculator part at all. So it's going to be something you can integrate by hand.
Is Form B like the one?
No. Form B is the ones for Europe. The one that if you missed the AP exam, and some of you may be in that boat because you're doing super mileage or whatever, there's conflicts, then there is another makeup exam, which is about 3 weeks later. Please let me know if you're in that boat, because I will get you what I can of this year's exam to look at. And that is just something we can't even see. I've never seen it, never graded the alternate exam. And even if I did, I couldn't talk about it. So, so there's really 3 exams. No, and what they're going to do this year is they've always released all the free response. They are not going to do that this year. They're going to release some of it. We cannot talk about the exam until they decide which ones they're going to release. So it'll be a few days before we can even get a little bit back. Same with the multiple choice. They don't release the multiple choice. Okay? They do it every 4 years or so, but that's not even predictable. Last one was 2008. So I would think they'll release this year's, but probably not. They did 97, 98, 2003, and then 2008, maybe even another year, maybe they'll release it. So finding coming up with good multiple choice questions is hard.
I don't think it's just
because they use them over and over again.
same ones.
Same ones. And they might change it a little bit. And if we have a chance, and we will, to go over some of these, I can share with you which ones have been repeated. You'll see it. Number 1, by the way, on this multiple choice packet is repeated later on, but this is an indefinite integral. It's repeated later with a definite integral. Girls, put the phone away, please. Okay? So these are important things to know. We are not going to come back and review this. Once you test on it, we're done. We're done. So we're not going to be doing this in April. In April, we're going to come back and review all the other things. Continuity, limits, derivatives, a lot of things I bet you've forgotten. But we'll review it. And I do have videos that will be put up online if you can't come to review sessions, assuming we have review sessions. I don't know. So let's do, not this problem, this is a B problem. This one's harder, although we could talk about it before we do the next one. I want, in part B, find the area of S, which is right here. And the problem is you can slice it horizontally or you could slice it vertically. Okay, Adam? If you slice it horizontally, and this question came up last hour, how do you know what the differential is? That's this little thickness right here. What would that differential be? The change in y or the change in x? Change in, this is what? The change in the y value, right? So that's dy. Now when I do my integral, this is why the differentials are so important. When I do, and that's when you get into the volume parts, it's going to be critical as well. And the reason students had problems on this is they skipped the differential and then they weren't thinking about which way they were slicing it, what the variable should be. The problem is my variables should be all y's in my integral, which means I have to take y equal to 4x squared minus x cubed and solve for y. I don't know about you, but I have no idea, not y, solve for x. I have no idea how to solve for x. It can be done. There's a formula for cubics. I have no idea what it is. It's not worth it. Okay, Adam, put the calculator away. So you can't solve for x. But normally I would slice it horizontally because it's just this line minus the curve. You have to look at the geometry. This is all geometry. So if I slice it vertically, it's the line minus the curve here. Does everybody see that? But what happens when I get over here? It's the line minus what? What's the value here? 0. So this is y1 minus y2. I'll label it y1. I'll label that y2. And this is y1 minus 0. So I have to set up two integrals. And there is no other way to do this problem because you can't solve for x. At least I don't know how to do it. And by the way, I was going to integrate this, but wouldn't there be an easier way to do this? It's a triangle. And it's perfectly okay to use the geometry. So the area of this little red region is 1/2 base times height. I'll leave it to you to find out where this value is and where that value is. And I'm going to show you some things with the calculator. It's not going to be appropriate for this year's exam about storing values for the area volume problem. However, it may occur someplace else in the exam where you have to store. You don't have to, but it's a lot better. So let's go to the next page and let's try that one because I can practice with my calculator here. Okay, so and if you can't see it, we can close lines a little bit more, but let R be the shaded region bounded by those two graphs, and I'm going to just color it in. It's this one. Now be careful. Don't assume that the y value on this bottom graph is 0. It's an exponential. It can't even be 0 if you think about it. Is e to the x ever 0? No. The only time e to the x is 0 is if it's translated, and that's not translated. Okay, so I want the shaded region. I'm going to bound it by x equals 1. Please read through the problem because they do give you a lot of information, by the way. And it says find the area of R. I have two ways I can slice it. I can slice it horizontally or vertically. Which way do you want to slice it? And I always show my rectangles. Vertically. If you slice it horizontally, I'm going to undo here. But if you slice it horizontally, it's the line minus that curve, and then it's the line minus the other curve. That's two integrals. You can do it. Plus, is this dy or dx? It's dy, which means I have to solve y equals e to the minus 3x for x in terms of y, which is very doable, but I know how you love logarithms. Not. So I'm going to undo what I just did, because you did tell me the best way to do it. We're going to slice it vertically, yes. I want to find this area. If I slice it horizontally, it's two different integrals because it's this line minus the e to the x curve, and it's this line minus the square root curve. So I can't do it as just one integral, unfortunately. Sometimes you have to. Like if you do the first question on the packet, you have to write two integrals. There's no other way to do it. But this one can be done. So I said the b's are a little bit harder. This one can be done. I'm going to draw my little rectangle in here. I'm going to label the top curve y1 and the bottom y value y2. So what's the area for one of these? For one rectangle. You can. It's just two integrals if you slice it horizontally. Usually you're going to want to slice it vertically, but not always. If you go through every single problem in this packet, you will feel comfortable to do this problem. And to me, honestly, this is one of the easiest ones. This and the differential equations are the easiest problems on the exam, especially if you look at 2011 and what we did last year. You're going to go, oh, that was really easy, but you do have to be able to integrate by hand. Okay, so the area of one rectangle is the base times the height. What's the base? Delta x or delta y? That's delta x. And the height then, how do you find this height? Yeah. Doesn't matter if the y drops below the x-axis because it's negative, and it'll be okay. Okay, so what I want to do is add them all up. So this is my plan. This is how I do it. And if you get y1 minus y2 and you see dy there, I can tell you you're wrong because y and x are perpendicular. When you set it up generically, notice I haven't done anything with the functions. It's the y and it's an x. The height is the y, base is the x, or vice versa. Okay. And now I'm lazy on the exam. I'm going to tell the grader that y1, I'm going to write it out, is, which one's the top one? The square root or e to the minus 3x? Square root. Is it easy to get it backwards? Yes. What's going to happen? What will your answer be if you do it backwards? Will it be positive or negative? Negative. So then fix it. If you get a negative answer, you're going, oh, I did it backwards. Okay, so y2 is what? E to the minus 3x. Could you do this integral by hand? Yes, you could. It'll be easier than that. No natural log. What's the antiderivative of e? E to the x. Well, I'll have a negative 1/3. But we're going to do it on a calculator anyway. So we're going to integrate, and I'm going to, as long as I've done this, I can just leave it y1 minus y2 in my integral, or I could actually substitute them in, and I need to integrate from, I don't know where this is. What would you like to call that? A? Can't call it 2. I don't know if it's 2. Oh, Q. Okay? Q. And they did tell you this one to what? To 1, right? There's my setup. I'm going to have to tell the grader what Q is. Not a problem. And we'll learn how to do those notations. So we need our calculators. If anybody would like to borrow one, they may. If you want to use an Inspire, you may. I'm going to do the 84 and show you how to store that value in. When you do this value x equals q, you have to, in your calculations, keep all the decimal places. You cannot round. I know you round in science, but you can't round here. So that's a problem. Okay, so we're going to clear that out. And then y equals, I'm going to put in, why is that still there? Okay, I got y1 is the square root of x. Now, this is okay to do this, but they don't want the calculator syntax. If you give them calculator syntax, you'll get nothing. As long as I clearly define what y1 and y2 are, I'm okay. So y equals, I'm going to clear that out, and that was the square root of x. Oh, this is going to be fun because I can hardly see it. My guess is it's right here. I guessed right. And I think you see square root on yours, correct? Yeah. And then we'll go down to y2, which is e to the minus 3x. It's interesting because on the Inspire, the E is the regular button, and you have to do the shift key to get the log, and on this one it's reverse. So, what? Oh, because that is, I'll change it. That's the circle trace button. But we don't care about that. We just want to find out where they intersect. So I'm going to press enter, and it'll now change to just the oh, I forgot that. Okay. Well, let me get this back. There's the dotted lines. There's the solid. When I clear it, it should fix it, but it doesn't. So negative 3. I could have inserted. It's just easier to do that. Okay, ready? Make sure you are in radian mode, although it won't matter here. I always zoom 4. I start there. But they gave me the domain. Mrs. Hersman likes the zoom fit. I don't like the zoom fit. I like to look at this a little bit better. So why don't we go window, and we'll start at x as the zeros. And how about if we go to 1? Because they gave it to me. Now you can zoom fit if you'd like. Zoom fit does not always work. In this case, it's going to look a little bit better if I zoom fit. Because nothing's negative, is it? So let's practice that, just for those of you who like to do that. It doesn't work when you do 3 to the x and x cubed. So if it fails, you're going to have to figure out your domain and range yourself. There it is. Always set your domain first, though, when you do a zoom fit. Beautiful picture. Okay. I pressed, first I did a zoom decimal, and then I changed the domain to 0 to 1, because it told me that. And I could have figured out the range to be at 0 to 1. It wasn't hard, but I pressed zoom fit. So we want to find out where this intersects. You guys remember how to do this, right? Second, calculate. Intersection. Now, because there could be more than one intersection, it's going to ask you for a guess. There is only one that I can see. So we're going to press enter. And then it jumps to the second curve. Enter. And actually on the Inspire, it's much easier. And then it says guess. Well, that's just there in case there's more than one place where they intersect. So we ignore it, just press enter, and we get the exact answer. There it is. Okay, so it's negative 2.387. Well, you know what? You'll have to write it on your exam. You have to write that on your exam. But when I do the calculation, I don't have to do that. So I'm going to quit. Now, in case you didn't know this, if I press X, wherever your cursor last was is your X and your Y coordinate. If I press alpha Y, uh-oh. What number is it above? I can't read it.
1.
1, okay. Oh yeah, that's because it wasn't at 0. So, oh, it's at 0, but that gives you the last place that cursor was. Okay, you guys in the back? That's the last place the cursor was. That's nice to know. So, if I want to store it, and in this case I don't even have to store it, but if I want to store it, I'm going to go second enter, because that's what your calculators do. I don't want Y, do second enter again. Well, let's just type in X again, because it's still there. For some reason I can't get it back. There it is. And then we're going to press store. The store button is right above, oh no, it's right here. Right next to the 1 and 4. We're going to store that in. And should we put, oh, we called it Q, didn't we? So let's do that. Oh, you're going to have to help me out. What is the Q?
Over the 9.
Enter. Okay. You will have to write this long number out. Include all the digits. Pardon? Shouldn't change. It should be 4.88 unless you move your cursor. If you move your cursor on your screen, that'll change. Okay. I want to clear my screen out. It's messy looking. And I want to integrate that. So remember how to do that? Math. Do you remember what number it is? 9. You could store this down to Y0. Nobody's going to clear your calculator. And we want to go from Q. So alpha Q up. I like to do the up next to 1. And then what I like about the way I do this right here, Y1 minus Y2, that's exactly what I'm going to key into my calculator. Make sure that you have defined it somewhere. So it's bars.
You store Y as
You don't. We didn't need it. But sometimes we do. You could put it in for A or B, whatever you want. Y1. I must have hit a button too soon. Minus Y2. Bars. Okay, you guys should be doing it with me. It's a function. If you don't have a calculator, you should get one. Don't think you're going to be able to do this in the time limit that you have if you haven't practiced. Oh, yeah. Sorry. Yeah, I know. And I can't get back to the old one. X. Looks just like what I have right there. That's what's really nice about it. Press enter, and I should have the right answer. Well, let me put this here. You do FNINT, and then you're going to do Y1 minus Y2, comma X, and we're starting at Q to 1. But even Q is this number here where they intersect, and you would say Q equals that. We stored it in Q. Are you on 83? You press the store button. I'll show you. So I want to take my X value. Okay, guys. There's X, right? And store is right there between the 1 and 4. Store it in alpha Q. Or wherever you want. Now, guys, shh. One thing that's interesting is, you guys, how do we find Q? We found the intersection of those two curves. Now, what's interesting about this is I can actually do this. I'm going to go math. I didn't have to store. If I have to store two values, then I'm going to have to do that store thing. But I could actually type in X, because X was 0.238. So I type in X, and we go to 1. And then we would put in y1 minus y2. Now, because I've got the new one, I'm going to use the easy way, the shortcuts. y1, for those of you who have the new operating system. If you have an 84, you can get the new operating system. But you want to get one before so you can practice it. Did I not press it? Oh, I have to press it that way. X. Okay. Press delete. Delete. Okay. Then arrow over to my X. Okay, that was not good. It would work. It won't give me the right answer. Delete. There we go. I'll press enter. At least I should still get the same answer point. What was that, 442? So see, I don't even have to store it. It's in X. That is not a variable. It's looking at it as a number. Now, what should you write on your exam? Here's what you should write. At least 3. You can round if you want to. You do not have to. It's probably 2. 1 for the integral.
It's only 2 points.
And 1 for... Oh, it doesn't take this long to do it. You can truncate, or you can round, or the safest thing is, write them all down. Okay, you guys, girls, listen carefully. If you write the first 3 correctly, girls, and you write all the rest wrong, we don't care. We don't read that far. We read the first 3 and we stop. So write them all down, and then you'll know you won't be in trouble. And why do I care about that? Because let's say you rounded to 2 places on every single problem on your free response. You have a different grader for every single problem. So you don't get the point taken off once. You get it taken off every single time. That's 6 points. That could be the difference between a 5 and a 4. So write them all out, and then you don't have to worry about it. If you say, oh, I can't remember how many places, give them all to us. Doesn't matter. Okay, so the rest of the time is for you guys to work on the problems. I have to run and get the answers because they're in the other room. I forgot them. Okay, I'll bring them in, and maybe I don't know where I'll tape them. I'll put them on the tables over there because nobody's there. And then tomorrow we will do the same thing. Well, but tomorrow we'll probably